Just the same review stuff, verbalizing more problems.
Okay.
So the first problem is f of x is equal to 2 parentheses x minus 3 squared.
I'm sorry, f of x is equal to 2.
And then parentheses x minus 3
squared.
Yeah. And then parentheses x plus 2 to the 5th.
Okay. I'm betting that you've learned about multiplicity.
Yeah, I think so.
Okay. So what's the question here? Graph this?
It said find all the zeros of the given function and tell whether they will cross the x-axis or the tangent to the x-axis.
Okay. That's all about multiplicity. First of all, to find the zeros, we're going to set it equal to 0. What's the solution? There's only 2 unique solutions. What are
they? X is equal to -3 and x is equal to -2.
It's always the opposite of those signs.
Oh, 3 and -2 then.
Yeah, in other words, what I'm technically doing is I'm letting that equal 0. So my answer is always going to be the opposite sign of whatever that is.
Okay.
It's a common mistake, but it's not always. In other words, you could have something like 2x. Let's say I had 2x minus 3 as that factor. Well, now if I set that equal to 0, then x actually ends up being 3/2. So I can't say that the answer is always just the opposite sign of that. The answer lies in setting that equal to 0. That's how you solve it, is you set this equal to 0 and you set this equal to 0. Okay, so one answer is x equal 3. How many solutions are there that x equals 3?
1.
Actually 2. That has multiplicity of 2. And the reason is that I could have just as easily written this as x minus 3 times x minus 3. Well, there's a solution of 3 there. There's a solution of 3 there. So that's why they call it a multiplicity of 2.
Okay.
Okay? So what's the other solution?
X equals -2 and
what's its multiplicity?
5.
Okay. Because that's really x plus 2 times x plus 2 5 times. So there are 5 solutions of x equal -2. Now, It's real simple after here. If you have an even multiplicity, it's tangent to the x-axis. If you have an odd multiplicity, it passes through. Okay? One way to remember that is if I have y, or we'll call it f of x, equals x squared. Well, I got x equals 0 as a solution, but the multiplicity is 2, correct?
Yeah.
And if I graph that, it bounces off the x-axis and goes back up. So I can always go back to this example, as long as I know that's a parabola that touches at the origin, then that tells me how to treat my multiplicity. And if I had f of x equal x cubed, well, that would be still 0, but now I got multiplicity of 3, and it crosses through the x-axis.
Okay.
So whenever your multiplicity is odd, which includes 1, it's going to go through the x-axis. Whenever your multiplicity is 2, or even, then it's going to bounce off.
Okay.
Okay. Is that it for this problem, or did they need to know anything else?
I think that was all, yeah.
Okay. What else you got?
So the next problem is, it just says negative 5i, but it wants, let's see, let me read the whole thing. It wants to just state the type of number, whether it's rational, irrational, or imaginary, and decide whether it can be seen on the x-axis as an intercept.
Okay, what's the answer?
It's imaginary.
Okay. And?
It cannot be seen on the x-axis as an intercept.
That's correct. If I have a quadratic that has imaginary solutions only, in other words, your quadratics are always going to have two solutions, or one solution with multiplicity of two, and it does not cross the x-axis, then this has two imaginary solutions. Imaginary solutions do not cross the x-axis.
Okay.
So if you had a cubic like this, cubics have three solutions. What kind of solutions does this cubic have? How many real, how many imaginary?
It has one real and two imaginary.
Exactly. And you can see that because there's the real. And we know there's going to be two imaginaries because it's a cubic. I suppose it could be a cubic that crosses the x-axis at one spot 3 times. And I can draw that. There is a cubic that crosses the x-axis at one spot, has multiplicity of 3. So it goes through the axis, but that's y equal x cubed.
Mm-hmm.
And there are no imaginary solutions to that. It's just 3 solutions of 0, multiplicity of 3.
Okay.
Okay. What else? Did they make you graph complex numbers?
I don't think they're making us graph it in any of these.
Okay.
Then the next one is rewrite a equation in standard form and tell the degree, the leading coefficient, and the end behavior of the statement.
Okay.
For the following. Yeah. And it's so negative 7x to the 5th plus 2x to the 8th plus 4.
Okay, how should I rewrite this? I don't need to rewrite it. What's the question?
It wants me to rewrite it in standard form.
Okay, go ahead and do that. Let's do that. Step 1, standard form is what?
Put 2x in front of negative 7x to the 5th.
So the whole thing is just rearranging and putting the highest degree polynomial in front. What degree polynomial is this?
It's the 8th,
right.
Or 8.
Right. It's always whatever that highest exponent is. Left-handed end behavior. What is it?
The end behavior would be negative.
Left-handed end behavior. And the answer needs to be negative or positive infinity.
So it'd be negative infinity.
No. When you're dealing with end behavior, the only term that matters is that one. Nothing else matters. And as all you do is you plug in negative infinity. It's not the way they tell you how to do it in the class, but this is a nice, quick, and dirty method of getting it. What's negative infinity to the 8th power?
Negative infinity. Or no, positive infinity.
That's the end behavior. In other words, as x goes to negative infinity, all the way to the left, y goes to positive infinity. That's end behavior. Now, what happens as x goes to positive infinity? What does y do?
Y goes to positive infinity.
Yeah. In other words, what it really has to do with whether that's an odd or an even number. If it's an even number, then the left-hand end behavior is always positive infinity. If it's an odd number, the left-hand end behavior is always negative infinity.
Okay.
Because if you plug in, let's make that a 7 instead. Okay? Now, when I plug in negative infinity and take it to the 7th power, what do I get?
Negative infinity.
Right. And when I plug in positive infinity and take it to the 7th power, I get positive infinity.
Mm-hmm.
So the graph with the 7 and the 5 is going to look something like this.
Okay.
In other words, it's going to start from negative infinity as we go towards negative infinity on the x-axis. And it's going to end up going towards positive infinity as we go that way on the x-axis.
Okay.
That's why left-hand and right-hand end behavior is important, especially when you get to a point where you can figure out how many loops there are and whether it crosses or bounces. Then pretty much any function, if you know it's zeros, you can graph it. If you know it's left-hand end behavior and it's right-hand end behavior and where it crosses the x-axis and whether it crosses or bounces, that's all you need to graph that function.
Okay.
What else?
So the next just wants us to simplify the expression.
Okay.
And it's x to the negative 4th. And then times x to the 12th over y to the negative 6th.
Okay. These you always just take one variable at a time. If there's numbers involved, like a 2 and a 6, you do the numbers first. Okay?
Okay.
In other words, if I had a 2 and a 6 there, I would change it to 1 over 3. Okay. So next we're going to take the x variable. What's x to the minus 4th times x to the 12th?
That's x to the minus 48.
You do not ever do the same thing to the exponents that you're doing to the base. What are you doing to the base? You're multiplying it, right?
Mm-hmm.
It's x times x. So I'm never multiplying the exponents. So if I'm not multiplying them, what should I do?
Add or subtract them?
Add. Always do one level less. One level less than multiplication is addition. Addition goes with multiplication. Subtraction goes more with division. Okay? So what do I have? X to what? I'm adding the exponents.
X to the 8th.
Now usually they will say do not give your answers with negative exponents. So what do I need to do to change that y to the negative 6th so that it has a positive exponent?
Y to the 6th, 1 over y to the 6th.
There's an easier way to do it than that. In other words, I could do this, but now I got x to the 8th all over 1 over y to the 6th. The easier way to do it is when you have a negative exponent, is all you have to do is move this thing to the other side of the fraction bar and make it a positive exponent. It's as simple as that. It doesn't matter whether it's in the numerator or the denominator. So the final answer is x to the 8th in the numerator, y to the 6th in the numerator. In other words, I can do it in one step. I get the same thing if I do it your way, where I do it this way. And well, now I'm dividing by a fraction, so I have to flip and multiply, and I get that. Okay? So I get the same answer. It's just that when you see a negative exponent and you want to change it to a positive exponent, just put it on the other side of the fraction bar. That's the fastest way to do it. Now, unless you have a situation like this, where I know that by immediately multiplying those two together, I'm changing it to a positive exponent. So I do that step first, rather than put that x to the 4th in the denominator, and then I got to do x to the 12th divided by x to the 4th, which still gives me x to the 8th. But it's a nifty trick, knowing that a negative exponent, you handle that by just moving it to the other side of the fraction bar.
Okay.
Go ahead.
Okay. So next one is f of x is equal to -2. And then parentheses x squared plus 3 minus parentheses 2x minus 5.
X squared plus 3 end parentheses?
Let's see. Yeah.
And then begin new parentheses?
Yes.
What's in those?
Oh, and put a minus in between the two parentheses.
Okay, hold on. Goes in that parentheses?
And then 2x minus 5.
Okay. And what do they want to know?
They want it to be simplify the function to standard form.
Okay. Which means getting rid of the parentheses, basically.
Okay.
And then combining terms.
Okay.
We know what standard form is. Standard form is ax squared plus bx plus c. That's what standard form is. So we're going to have some number of x squareds, and then we're going to have some number of x's, and then we're going to have some number. So the way to accomplish all of this is to eliminate the parentheses. So let's do that first.
Okay. So I'd want to subtract first, or
just read the line. You can eliminate both parentheses in one operation.
Okay. So negative 2x squared minus 6 minus 2x plus 5.
Good. Now the only thing that you can combine the numbers.
So that would be 2x squared. No, negative 2x squared minus 2x minus 1.
Okay. And that's it. That's all they ask you to do, right?
Yeah.
Was to write it in standard format or anything else? They want you to factor it or anything like that?
No, just simplify it and write it in standard form.
Okay, that's it. Notice that that's ax squared plus bx plus c.
Okay. So then again, it wants to simplify the expression 2x to the 5th over 9y to the negative 2nd. And then that's all in parentheses, and then there's a -2 to the negative 2nd.
Like that?
Yeah.
Okay. What is this?
So that's x squared times x squared times x. Oh wait, no, that's just x to the fifth.
No, you're not going to add those exponents. You're going to multiply them. Notice
Okay.
what we're doing here. We're not doing multiplication. We're doing exponentiation. Twice, in fact. Some people would call that double exponentiation. So we're never going to do the same thing to the exponents, but we can multiply those exponents. That's one level less than exponentiation is multiplication. So it's x to the sixth. Okay, so whenever you have double exponentiation, you want to multiply the exponents. Now, the fact that we have a quotient doesn't really matter. If I have a over b, and I take it to the minus 3 power, that's the same as a to the minus 3 over b to the minus 3. In other words, I operate there by multiplying it by that one to get that, and multiplying it by that one to get that. So we're going to basically do that on this problem. We're just going to apply the double exponentiation rule to the top and then the bottom, and then we're going to simplify it. So, apply it to the number.
So that would be 2x to the negative 10th.
Okay, that negative 2 applies to that big positive 2 also.
Okay.
So here, let's do it like this. With me?
Yeah.
Now give me the denominator.
So that would be 9 to the negative 2. Y to the positive 4.
Okay. Now let's simplify. What can we do with those two things right there?
We can divide them. So
move them to the other side of the fraction bar. In other words, move that there and move that there.
Okay.
Notice that that becomes very easy. That's 81 over 4. Whereas this is 1/4 over 1 over 81. So if you don't switch them, it becomes a harder problem. In other words, by turning them into a positive exponent immediately, it makes it much easier.
Okay.
Okay, so that takes care of the number. Now what am I going to do with that x to the minus 10th?
You're gonna make it 1 over x to the 10th.
We're going to just move it to the other side of the fraction bar. We're not really going to make it 1 over. In other words, we already have a numerator. It's 81. So is what I'm going to do is I'm going to put it right there like that. I don't need to write the 1. Now what am I going to do to the y to the 4th?
You're gonna put it over to the negative 9 to the 2nd, so it'd be...
No, it's got a positive exponent already. I'm going to leave it right where it is. Now I'm going to simplify that. The numerator is 81. The denominator is 4x to the 10th, y to the 4th. You seem puzzled? Do you understand what I did?
Yeah.
Okay. You only move it to the other side of the fraction bar if it has a negative exponent.
Okay.
If it's got a positive one, then it's exactly where it needs to be. The x to the minus 10th had a negative one, so I had to move the whole thing to the other side of the fraction bar. Now, if you don't have a fraction bar, like if I have something like this, Well, that's where you have to put the 1 in. Okay? But if you already have something in the numerator, then you don't look at it like that. You look at it as, I'm going to take that x to the 10th, I'm going to put it on the other side of the fraction bar, and I'm going to make it x to the positive 10th.
Okay.
All right. Got a few minutes. Got time for another one for sure.
Yeah. Okay. So this one is parentheses 3 times 10 to the negative second.
Hold it. Parentheses 3 times 10 to the negative second, like that.
Yeah.
End parentheses or more to come?
Oh, yeah. In parentheses.
Okay.
And then times parentheses 4 times 10 to the 6th and parentheses.
Okay. What we have here is actually scientific notation. I mean, if you go all the way back to your 5th grade class and make that look like that, 3 times 10 to the minus second, that's scientific notation. Okay, and the way you do these is you multiply the numbers and then you multiply the other. So 3 times 4 is what?
12.
Times 10 to the what?
To the 4th.
Okay, now that is a legitimate answer, but it's not scientific notation. Scientific notation dictates that this number has to be between 1 and 10. So, if they ask for this answer in scientific notation, I got to make it 1.2 times 10 to the 5th. Which is,
okay.
Those are equal, same numbers. It's just that I now have it in proper scientific notation.
Okay.
Okay. And if you have to go the other way, let's say I ended up with a 0.12, well, then I subtract 1 from the exponent. And that would become 1.2 times 10 to the 3rd.
Okay.
If you're moving to the right, you add. Moving to the left, excuse me. If you're moving to the left, you add. If you're moving to the right, you subtract.
Okay.
You can always figure it out by just looking at a number. In other words, let's look at 20. What is 20? It's 2 times 10 to the what?
10 to the first power.
Okay. So what I had to start with was actually this. I had 20 times 10 to the 0, which is 1. And so I moved the decimal point left 1 spot to get it to 2. And therefore, I had to move the exponent up 1 number to get it to 1.
Okay.
So if you ever forget which way to go on scientific notation, just go back to a real simple situation where you know what 20 is, or you know what 10 is. You know what I mean? Or you know 100. 100 is 10 squared.
Yeah.
So that's 1 times 10 squared. That's 100.
Okay.
Okay. All right, Jonathan, you good to go?
Yep.
Okay. I'll talk to you next time.
Yeah.
Bye-bye.